Next, dirt and soiling. And we already know dirt, what exactly this dirt and soiling. This is like day to day. See, we are cleaning our houses every day. I cannot say I cleaned today, I will not clean up to 1 month. I cannot say those words because every day dust, it is not visible, but if you clean a swipe, you can see how much it is there. So similarly, we are implanting our PV modules outside. It is like outdoor application, not indoor. So outdoor means definitely dirt will be built on the surface. And due to that, because your cell efficiency of receiving the irradiation will goes down technically, is it? And of course, outer look, it is going to create a layers. So layers means the capacity or receiving capacity of the collectors will reduce it. It act as a shadow. It will act as a covering the surface. So due to that, your conversion of energy will definitely reduces. So here, that overall part of dust accumulation on the surface. So we'll separate the concept. Dust and dirt is one concept. Okay. So dust accumulation over the surface of a module, we call that as a soiling. And due to that, your output will not be reached as the expected. So it is creating a loss. You can call that as a soiling losses. I can read that losses caused by the buildup of dirt on the modules are often known as soiling losses, or often known as what? Soiling losses. So in the first module only we have discussed what are all the chances and what are all the things can be accumulated. So here they're given dirt, debris that can be placed or that can be going to cover the surface of a PV module. So leaves means definitely they will shade. Dirt means it will accumulate, which is not visible, but still that will going to reduce the output of a system. So here, this dirt and soiling is depend upon your orientation also, how you're placing your collector. Because we know so many different types of mounting systems are available. In most of the pictures we have seen, they are in a slant position. If not, your roof will be in a tilted position or a slant position. So if that is the case, then we can say, okay, fine. Somewhat it is cleaning by its own because the customer or a consumer, what we are using it, we are not going and cleaning or sweeping that collectors every day. We are not doing that job, is it? So it has to be done naturally. So that's what you can reduce that power losses by making a proper tilt angle or a proper orientation. Because one of the natural gift that is a rain. So if it happens, so it will going to clean and wash it. If it is slant, definitely it will wash away the dust also, wash away that leaves also. But if you think if it is not slant, if it is completely horizontal, like a sleeping line, so what happens? If rain comes, whatever it is, again it will create more accumulation at one particular cell where the cell cannot operate at all. So that problem you will go to face it. That's what they say. The reduction in power output will depend largely on the site and the factor influencing soiling, which are the factors that is tilt angle at which the modules are installed. Okay. So as we say, if roof is tilted, okay, you can implement as per the design. If not, try to make it as a small tilted type of a mounts. Okay. So the dust level on the site, and of course another factor where you are locating. Some areas, greeny areas, you can assume leaf will be going to shutter on the surface, or else let us assume you're there in the constructing area. So constructing area or near roadside. So because of vehicles movement on the dust will be accumulated much more than the area where you're out of the city, out of your urban areas. So that will also specify how much efficiency you are getting lost there. So dust level on site, local pollution that may form a film on the glass, and you have to think about the frequency of rainfall. So place wise or region wise, we have a different segment. See, if you say in Bangalore itself, we say, okay, near our college we are getting a rain. But if you go near Unsamanali also, you're not getting rain. Only small distance of 3-4 kilometers, we are finding a so much of difference. Is it the same way? So that is all environmentally happening cases. So that also we have to consider how many one months it is happening. Is it area is really we're getting rainy or desert area, so you cannot find it, is it? So those all parameters has to be considered for dirting and soiling condition. If not, of course, manually the maintenance has to be carried out. So in that case, So as we know, dirt derating factor, how it will be evaluated? There are two cases. One is, as we assume the place is having a less dust and frequent draining is happening, frequent draining area. So in that case, what happens? It will clean by itself. So your work or your maintenance will be reduced. So in that cases, and another one where you not have a frequent draining. So in that case, what is the calculation? So you can see here the derating factor due to soiling can be only estimated. It is a fairly common practice to use F dirt as 0.90. 0.90 normally they take it as first case, that is 10% output reduction due to soiling. Okay, for very dirt site, means this is like you're assuming it as a the place is having a frequent rainy and your tilt angle is proper, so that you can assume just 10% reduction in the output due to soiling system. But the area where you don't have a frequent rainy and all, in that cases, you are considering it as very dirt site. So this is for very dirt site 10%. But another one, sorry, add dirt where you are assuming frequent raining and all. So this is just 5%. Means it is washing by itself and no need of much maintenance and all. So you can consider it as 5%. So 5% for the area where you have a frequent rain and 10% for area as lesser than that condition. So dirt and soiling will also affect your output of a system. So next is manufacturer tolerance. So I hope this is already used in the calculation part. Manufacturer tolerance, it will be given in terms of positive or negative. So this is based on the capability of your power output. If you consider one module, they'll say this is 315 watt will be given, 350 watt will be given. So in that case, plus or minus values will be added as a tolerance, as your resistance. See, when you see the color coding, we have one more term called tolerance. You're going to add it as a silver, you're going to add it as a gold based on a color. So here also same thing, that manufacturer tolerance accounts for the small output variation between individual modules. This varies with respect to the places or countries. Some company you can say that company will going to give this modules have +3, one particular company. Another company will say -5. I think these are the two standards they are using it, and this was given in this book. So -3%. So in that case, the peak power of the module may be 3% less than the given data sheet. -3. So if you assume your actual output voltage of the module is 315, in that case, what we have to do? We have to minus minimum 3%, because it is given 3% of tolerance has been added up. So that's what it is minus. You have to remove that, and your guys are going to get the output as 305.55 watt because of -3% of tolerance. Similarly, if you consider a positive tolerance, so +5%, please add that 315 plus 5%. So your output will be more than 315, that is like 350 something you're going to get it. So that's what every time you have to observe the data sheet, what exactly it is given. Is it a plus tolerance or a minus tolerance? So next is shading. So shading, of course, it is like almost the same as your dirt and soiling process. The effect, it is not accumulation, it is definitely the shading portion will be varied as the day moves off or the sun movement goes from morning to evening. If you have a neighbor building is higher than your houses, or you are staying near a hill station, or you have constructed a chimney, you have so many cable dishings and all. So in that cases, it is like purposefully the shadowing we are creating it, is it? So shading can be a major contribution to loss of the system performance for two main reasons. So before saying this, I will say shading, there are two category you can find it. One is partial shading, another one is fully shading. So partially shading is mainly with respect to voltage parameter, and fully shading is mainly with respect to your short circuit condition. Partially shading means what happens if you assume, let us think. So this is your module. So in that module, only one cell only one cell is get affected, and remaining portions are getting a proper radiations. Okay, so this is called partial shading. Here, this is only a port where you're not having a conversion and losses are happening because this cell is not contributing anything, not converting anything. But what happens due to this radiation area, huge heat will be concentrated on this particular cell and it can damage the output of a module. The module in the sense your cell. Cell damage can happen and it persists for a longer time, then it will affect your module output. Similarly, if you consider complete shading. So complete shading means what? Your module output will be completely nil, is it? So, but the thing, your shading will be taken part by part sometimes, or half of the area will be covered. So that we have to think it. So in these cases, normally when we implement for PV panels, bypass diode will be connected. Means you people are creating a minimum flow path for the current so that you will have a continuity. Because let us assume you are having a 3 segments of module here and you are all connected together because we are making in a series combination, then connected to parallel, and afterwards you're drawing the power. In that, if mid one is not working and first and second are working, then this mid should not affect your first and second, third port, right? So in that cases, what they'll do, they will use two kind. One is bypass diode and one is blocking diode. So that will be used, and so that it will help for the module performance and safeguarding your modules. Okay, so this is exactly how shading will affect. So we'll see here what exactly. Hello, somebody wants to speak? I don't know. Is it audible, right?
Yes, ma'am.
Okay, fine. No, somebody raised the voice. That's what. Okay. Shading leads to a voltage drop, and if enough of the PV array is shaded, the voltage may drop outside the inverter voltage window, causing the inverter to turn off and the system will produce no power. So here, this shading we mainly concerned about the conversion energy. Already your inverter will be selected based on the PV capacity. So, and the limitation is already given. So in the last problem, we know that the range has been given between 264 to 600. 264, minimum 264 must be reached your input of inverter. Then only it will take off for the conversion process. But if it falls below that, then your inverter will not turn on to make the conversion of your energy. So in that case, if you're shading, I don't know how much far it is going to shade. It's a full cell or a half cell or a quarter cell. So depending upon that, there is a drop in voltage. And this drop that can cause the output, what we are drawing from the PV panel can be less than the requirement of your inverter input. So that is one case where your inverter will not turn on and gives the power output. So what we say that the system will produce no power. Means no power means no conversion, nothing you're going to get it. Another one where multiple strings are connected in parallel. The shading on one string may impact on the other orders. So this is because current and voltage are directly affected by the irradiance received. And when the module is shaded, it does not receive as much irradiation. So let us assume this as number of strings, because when you go for a huge range and all, it will not be one or two. You'll have a multiple strings. Definitely, back to back, it will be connected and you're drawing the power. If one cell is affected, your definitely efficiency will goes down. And shaded area, it will not receive much radiation, much conversion. And I also already told you the silicon, it will need minimum 1.1 electrovolt conversion at a time. If it is less than that, then the photons cannot be used. The shaded area normally it faces the problem like conversion of energy because of low value. It will not take place. So that will going to affect your output in terms of current and in terms of voltage. Voltage drop will also happen and movement of current will not take place, and that create a less power or no power in the output of a system. Okay, so this is with respect to shading. I think I have one of the data sheet where it shows the tolerance and how the value has been given with minimum and maximum. You can see it here. So this electrical data sheet has been given based on standard conditions, that is 1000. That is the irradiance, minimum irradiance, 1 kilowatt per meter square, and your air mass is 1.5. The temperature expected is 25 degrees Celsius. See, they have given the derating factor, particularly with respect to mechanical tolerance, that is +5, -3. So, but standard value is how much? 350. Which one you are using? Based on that, you add +5% or -3%. And next they're given rated voltage, it is 54.7, current has been given 5.76, and next major parameters for calculation: open circuit voltage, short circuit current, that is 64.6 and 6.14, and system voltage has been given 600. And you can see the temperature coefficients with respect to different conditions like power, voltage, current has been given here. And finally, fuse rating. So series fuse rating, this is very important to see from electrical data so that you can find out, is it necessary to have a production system or not. If it is below this value, you say no need of production devices. But if it is more than this, definitely we have to go for a fault protection in terms of overcurrent relay, overcurrent protection, lightning, grounding, all these things have to be considered. Fine. This is one of the important topic where they can ask you in exam, and please elaborate it. Don't minimize your answers because it will be asked for 8 to 10 marks. Try to give major importance with respect to the points and highlight it. Okay. Any doubts regarding this?
No, ma'am.
Only one answer I'm getting, only Soundarya. What about others?
No, ma'am.
Only no is the answer. How many people are experiencing this? Because how many of you are using this application of solar PV cells in your houses? Most of you? Sai Ramesh, Shashikant, Bharat.